Hello everyone, I am your friend Shadab Imam and currently we are dealing with the topic of CPM and PERT. In today's lecture, we will see PERT analysis in detail with an example problem. So in PERT analysis, the time required to complete the activity is not certain, and because of the uncertainty in carrying out an activity, the PERT analysis is probabilistic in nature, whereas a CPM activity has a fixed time, which makes CPM a deterministic model. So in CPM there is a fixed time, and in PERT we have three estimated times. So let us see here. In PERT analysis, activities have three estimated times: optimistic time, most likely time, and pessimistic time. Now optimistic time is the shortest time because all the things goes in favor of the project. So this is the shortest time. Most likely time is more or less an average time because of the normal condition of working. And the third, pessimistic time, is the maximum time that activity can take because all the things go against the project. So these are the three time estimates that we used in PERT activities. Now when we plot these activities on a graph, then we will find a certain distribution system which is very similar or closer to beta distribution system. So in this PERT analysis, we will assume that the PERT activities will follow beta distribution system, whereas the project completion time in PERT follows the normal distribution system. Now we need to remember one thing in normal distribution system, that in normal distribution system the expected project completion time has 50% probability. This means that the expected project completion time, this may also be termed as average project completion time or the time taken by the critical path. So once we calculate the critical path, the time taken by it is the expected project completion time, which has the probability of 50%. Now let us see what are the steps to find out the probability of a project to be completed at a given time. So let us see here. So it is a basic two steps process. First is to find the critical path. First is to find the critical path. Now we know that how we can find the critical path, but in order to find the critical path, we need to have a single fixed time. So what we will do is we will calculate one term which is called expected time for activity. Expected time, which is generally represented by TE. So this is the expected time for activity, and this is equals to optimistic time plus 4 times of most likely times plus pessimistic time divided by 6. Now using this formula, we can convert the three time estimates into a single time. And now using this single time for an activity, we will calculate the critical path. So step 1 is to find the critical path, and in order to find the critical path, we need to find out the expected time for each activity. That is, it is equals to optimistic time plus 4 times of most likely times plus pessimistic times whole divided by 6. Now the second step is to calculate the standard normal variate, and this standard normal variate is represented by Z. Now this Z can be calculated or can be expressed as Z equals to T minus TCP divided by sigma CP. Now let us understand what these values are. So let us see here. T first is the desired time. desired time of project completion. That means this is the time for which we are willing to find the probability. So if we need to find the probability of completing the task in this time t, this is our desired time. And TCP is the time taken by critical path, or we can simply say that this is the expected project completion time. Expected project completion time. And now along with this there is a sigma CP. So sigma, we know sigma, that sigma is a representation of standard deviation. So sigma CP is nothing but standard deviation of critical path, and this can be calculated using the formula sigma CP is equals to under root of sum of the variance of critical activities. So this is a simple two-step process. First is to find out the critical path, and in order to find out the critical path we need to have the expected time for each activity, which is nothing but equals to T0 plus 4 times Tm plus Tp divided by 6. And after that we need to calculate the standard normal variate, which is represented by Z, and this is equals to T minus TCP by sigma CP. Now T is the desired time for which we are calculating the probability, TCP is the critical path time, and sigma CP is the standard deviation of critical path. Now standard deviation of critical path is calculated using this formula, which is the sum of variance of critical activities. Remember here that standard deviation of critical path is not the summation of standard deviation of activities. That will be incorrect, and so the correct formula is sigma CP is equals to under root of sum of the variance of the critical activities. So once we will find the value of Z, we will see the normal distribution table, and in normal distribution table we will find the probability corresponding to this value Z, and that will be our final answer. So we have seen how to calculate the probability of the project. So let us start to our problem. So the problem says that consider the following project details. So these are the project details where these are activities and these are 3 time estimates: optimistic time, most likely time, and pessimistic time. So it says that draw network diagram. First one is to draw the network diagram, then to calculate the expected time and variance for each activity. So we will see how we will calculate variance here, and then find the critical path, and then finally find the probability of completing the project in 12 days, 14 days and 10 days. So I have already made 2 columns here. First is expected time for each activity and the variance of each activity. So let us start solving here. So I am just erasing this so that there will be space to solve the problem. So the first point, it says that draw the network diagram. So let us draw the network diagram here. So initially activity 1, 2, so we'll take 1 as the starting event, and 1 to 2, this will be your activity 1 to 2. Now second is 2 to 3, so let this be here. This is activity 2 to 3. Then activity 2 to 4. So let us have this activity 2 to 4. then activity 3 to 5. So let this be activity 3 to 5, this is 5. Then activity 4 to 5, so this is activity 4 to 5. Now activity 5 to 6, so let this be activity 5 to 6. So we have done the network construction part. Now the next is to calculate the expected time for each activity and the variance for each activity. So we have seen, in order to find out the critical path, we will use to calculate expected time TE, which is given by this particular formula, and we need the variance for each activity in PERT analysis, because in order to calculate sigma CP, which is standard deviation for critical path, we require the variance of critical activities. So in order to find sigma CP and the value of Z, we require to calculate the variance of critical path. Now let us see what is the formula for variance. So first of all, let us understand sigma. Sigma is the standard deviation. Now sigma for each activity or any activity can be given as TP minus TO divided by 6. So this is pessimistic time minus optimistic time divided by 6. This is the standard deviation, and the variance, variance is the square of standard deviation, or we can simply write here that TP minus T0 divided by 6 whole square. So this is the formula for variance, this is the formula for standard deviation. So we require variance to calculate the probability. So we will calculate the variance and expected time here. So let us start calculating. First we'll calculate the expected time, which is the optimistic time plus 4 times most likely times plus pessimistic time divided by 6. So this is 3 plus 1 4, 4 plus 2 into 4 is 8, 4 plus 8 is 12, 12 by 6 is 2. Similarly here 7 plus 1 8, 8 plus 4 into 4 16, 8 plus 16 is 24, 24 by 6 is 4. This is 9 plus 1 10, 10 plus 8 18, 18 by 6 is 3. Similarly here also 18 by 6 is 3. This will be 4 plus 2 6, 6 plus 4 3 is 12, 6 plus 12 is 18, 18 by 6 is 3, and here also it is 18 by 6, which is 3. So we have calculated the expected time for each activity, and now this expected time will be used to calculate the critical path. So I am just writing these values here. For activity 1 2, time is 2 days. For activity 2 3, time is 4 days. For activity 2 4, time is 3 days. For activity 3 5, time is 3 days. For activity 4 5, time is 3 days. And for activity 5 6, time is 3 days. And now we will calculate the variance for each activity. Now the variance is given by TP minus T0 by 6 whole square. So this is 3 minus 1 2, 2 by 6, that means 1 by 3, and the whole square of 1 by 3 is 1 by 9. I am writing in fraction just to avoid the rounding of error. Okay, so this will be 7 minus 1 6, 6 by 6 is 1, 1 square is 1. This is 9 minus 1 8, 8 by 6 is 4 by 3, so this will be 16 by 9. Similarly here also this will be 16 by 9. This will be 4 minus 2 2, 2 by 6, that means 1 by 3, so 1 square of 1 by 3 is 1 by 9. So, and this will also be 1 by 9. So the second part is also completed, and we have find out the variance for each activity. Now let us calculate the critical path for this given network. So I am just erasing this portion. Now in order to calculate the critical path, we need to find out the earliest and the latest time. In order to find the earliest time, we will use forward pass method, and we will start from the beginning node or the starting node. So here the value of E1 will be equal to 0. So as we move ahead, if there is a single arrow coming to this event, we will simply add this value, and if there are more than one arrow coming, as in case of node 5 there are more than one arrow, then we will consider the maximum value among these two. So let us start solving. As at node 2 only a single arrow is coming, so we will simply add this time. So 0 plus 2 is 2, so E2 is equal to 2. Now moving on to node 3, we have a single arrow coming in, so this will be 2 plus 4 is 6, so E3 is equal to 6. Now moving to node 4, only a single arrow is coming, so this is 2 plus 3 5, so E4 is equal to 5. Now moving on to node 5, we have two arrows coming in, so we will consider both the values. So this is 6 plus 3 9, this is 5 plus 3 8, so we will take the maximum value, that means E5 is equal to 9. Now moving on to final node 6, and we can see that only a single arrow is coming in, so we will simply add this value. This is 9 plus 3 is 12, so E6 is equal to 12, and this shows that this is 12 days. This is our project completion time, or we can say time, or we can say average time of project completion, or we can say expected project completion time. And now we will calculate the latest value. So we will calculate the latest value using the backward pass method, which is started from the final node. And in latest times, we will first assume the initial value L6 as equal to the final value of the earliest times. So this is assumed as 12. And now as we move ahead, if there is a single outgoing arrow from this node, we will simply subtract this value from the latest time. And if there are more than one arrows coming out, as in case of node 2, more than one arrow is coming out, then we will select the minimum value for the latest time. So let us start solving. As we can see that from 5 there is a single outgoing arrow, so we will simply subtract this. 12 minus 3 is 9, so L5 is equal to 9. Now moving on to node 4, we can see that there is a single outgoing arrow, so we will simply subtract this. This is 9, 9 minus 3 is 6, so L4 is equal to 6. Moving on to node 3, we can see that only single outgoing arrow is here, so we will simply subtract this. This is 9, 9 minus 3 is 6, so L3 is equals to 6. Moving on to node 2, from node 2 we are having two outgoing arrows, so we will consider both the values. So this will be 6 minus 4 2, and this will be 6 minus 3 3. So for latest time we will select the minimum value here, so we will take the value L2 equal to 2. And now as we can see a single outgoing arrow from here, we will subtract 2 minus 2 will be 0. So we have calculated the latest and the earliest times, and now we will see at which nodes the value of E and L are equal. So we can see that for node 1 E and L are equal, for node 2 E and L are equal, for node 3 E and L are equal, for node 4 E and L are not equal, at node 5 E and L are equal, at node 6 E and L are equal. And now we will draw another line to show the critical path here. So let us, so this will be this and this. Okay, so our critical path here is given as 1 2 3 5 and 6. 1 2 3 5 and 6. So we have find the critical path. So we have solved the first three parts, and in order to solve the fourth part, that is to find the probability of completing the project in 12, 14 and 10 days, we need to calculate the value of Z here. So let us calculate these values. So first of all, we require to calculate the value of Z, which is given by T minus T Cp divided by sigma Cp. So here for first part, that is part A, the time T is 12 days. We need to find the probability of completing the project in 12 days. And TCP is time for the completion of critical path. So this 12 is TCP and divided by sigma Cp. So first I am writing TCP is equals to 12 days that we have calculated here. And to calculate sigma Cp, we need to follow this. This is summation of variance of critical activities. Okay, critical activities. So by this we can calculate the value of sigma Cp. So let us calculate the value of sigma Cp here. So sigma Cp is equals to, and now we can see that what are the critical activities. So we will see activity 1, 2 is the critical activity. So this is critical activity here. Then activity 2, 3 is the critical activity. So this is the critical activity. Activity 3, 5 is critical activity. So activity 3, 5, this is critical activity. And activity 5, 6 is critical activity. So these are 4 critical activities here, and we will find the summation of the variance of these 4 activities. So this will be 1 by 9 plus 1 plus 16 by 9 plus 1 by 9. So this will be 16, 17, 18. 18 by 9 is 2. 2 plus 1, 3. So this is equals to under root 3. And we know that under root 3 is equals to 1.73. So this is the value of sigma Cp. Now let us calculate the probability for 12 days. So first part A, where time T is given as 12 days. So for this, the value of Z is 12 minus TCP we know is 12. So 12 minus 12 divided by sigma Cp, which is 1.73. 1.73. Now this is equal to 0. And we should know that for Z equal to 0, the desired time T is equals to time for critical path, or we can say that expected time for the project. So when these two are equal, and we know that the according to normal distribution table, the probability for critical path, or we can say that the expected project completion time is 50%. So we can directly say that for Z equal to 0, the probability of completing the project is 50%. So for 12 days, the probability of completing the project is 50%. Now let us look at the second part, where desired time T is 14 days. Now for this, we again will calculate the value of Z, that is 14 desired time minus TCP, which is 12 days, divided by sigma Cp, which is 1.73. So after calculating this, we will get the value as 1.16. So once we have calculated the value of Z as 1.16, we will look into the normal distribution table, and in normal distribution table we will find the value of probability corresponding to this value of Z. So as I have already calculated the value from the table, so the probability for this particular value of Z probability for this particular value of z is coming as 0.877, or we can say 87.7%. So now let us move on to the third part. So for this, the desired time given is 10 days. So we'll calculate the value for z. This will be 10 minus 12 by 1.73. So now after calculating this, we'll get the value as 1-1.16. So as we can see here, the value of z is coming as -1.16. So what we'll do here now is we'll calculate the probability corresponding the value of z 1.16. So we have already done it here. We have calculated the probability at 1.16, which is coming as 0.877. So for this -1.16, the probability will be 1 minus 0.877, which is equal to 0.123, or we can say that 12.3%. So for this, we will simply subtract the probability for 1.16 by 1, and this will be our required probability for completing the task in 10 days. So as we can see here that for 12 days the probability is 50%, for 14 days the probability is 87.7%, and for 10 days the probability is 12.3%. From where we can say that for the average project completion time, which is 12 days here, the probability is 50%, and as the time, or we can say as the desired time increases, or the desired time is more than expected project completion time, as in second case, the probability is greater than 50%, and if the desired time is less than the expected project completion time, then the probability is less than 50%. So I hope this is clear. If you like the lecture, please share the lecture. Have a nice day. Thank you.